What's up everybody, my name is Dean Chessman and I'm really hoping today that this tutorial will help get you up to speed with TouchDesigner. And my whole purpose of this tutorial is I want to get you familiar with the UI, the vocabulary, and the basic tools so that you can work through other tutorials and understand what workflows are available with this amazing tool. Real quick to introduce myself, my name is Dean Chessman. I'm a freelance creative technologist. I've been using TouchDesigner since 2018. I live in Provo, Utah, and by far from all the softwares I've ever learned, TouchDesigner is my favorite. I've spent time as a motion graphics designer, a UX designer, and generative coding artist. And by far, TouchDesigner is my favorite tool that I've ever used and ever learned, and it's something I think I'll stick with for a long time. So if you want to see some of my work that I've done, you can visit my website or my Instagram. If you download this project file, I'll talk about how to do that at the end of this project or at the end of this tutorial. You can use these and click on these links or click on these like buttons, and they will open up a separate browser with my website or my Instagram on there. Also, as you may tell, I make tutorials, so if you check out my website or check out my YouTube channel, I've got multiple tutorials that hopefully this tutorial will prepare you to then watch those tutorials and learn more. I also have a Patreon account here that if you follow along my tutorials but you want to download the project files, or if you want to skip my tutorial and just get the end project file, being a Patreon supporter is a way to get that. I will make this project file for this tutorial available on my Patreon for free. Actually, this whole tutorial and the project file I'm going to make available all for free for anybody that wants to learn how to use TouchDesigner. Okay, let's jump in and get started with the UI. So in TouchDesigner, you'll see this main window here in the middle with this gridded background. This is called the network editor. And to move the network editor around, you can left click anywhere on the background and drag it around. To click on any of these elements here, you can middle click and see this amount of info. You can also drag and select things with the right click button. So with your right mouse button, you can right click and drag to be able to select multiple items. And then also you can right click on things to get this contextual menu. Right clicking on an operator and on the background will give you different right click contextual menus. As I have mentioned, these different boxes you'll see in the network editor are called operators. And operators are kind of the main tool that you'll use throughout TouchDesigner, and I'm going to take a lot of time in this tutorial to go through kind of the different types of operators and what they mean, what they can do. Also continuing around the UI, here at the bottom you'll see there's the transport, so you can actually play and pause. Those are kind of the two main ones that are actually used here. You can also go backwards. I've almost never used that, or rewind to the beginning. I've never used that. Sometimes I'll pause and step forward one at a time. That's what this plus button will do. But for the most part, you will just use play and pause. Hitting spacebar while nothing is selected will play and pause the touches. Hitting the spacebar will pause or play, toggle between pause and play in TouchDesigner as well. So if you, for whatever reason, you notice like TouchDesigner seems to stop doing anything, it might be that you've accidentally hit spacebar and paused it. Then there's also, in this bottom left area, you can kind of ignore most of these things except for this FPS. This is where you actually set the frame rate of your project. You can click that and change it. So if I change this to 30 frames a second, you might see that then reflected here at the top is this actual what our frame rate our project is currently running at. So if I'm going to go ahead and change that back to 60, and you'll see here at the top my frame rate jumps back up to 60. Some other things that you'll probably see when you have your TouchDesigner open, you probably, when you opened it up, had this menu in the top right whenever you selected an operator. I had that turned off, but what this is your parameters window. And it's important you call this parameters because that vocabulary gets used in very particular ways. So it's not an attribute, it's not a variable, it's parameters. And this is where you can change the values or the different settings for the different operators. You'll notice as I click on different operators, I get different parameters that show up. And then I've typed in the name of this custom variable, and if I need to, I can stretch it out to see more. And then I can change the value of this by either clicking and dragging on a slider that's there, or there's what's called the value ladder in TouchDesigner where I can middle click on it and then change in increments by going left and right on this ladder. So if I'm on this 0.1 and go left and right, it'll change in increments of 0.1. If I go up to the 1 and drag left and right, it'll change in full increments of 1. And then if I go all the way up to tens, I can change it by tens. You can, if you don't have a middle click button, like, or if you're using it on a laptop with like a touchpad, you can click and hold for a second, and then the ladder will show up. As I kind of was illustrating before, if I don't have anything, if I'm not pressing on anything, I've hit P, it will get the parameters to show and hide. And then also, if I want to see, like on a more complex operator like this math operator, you'll see there's multiple tabs, and I might not know, especially if I'm downloading somebody else's file, like I want to see what's changed. You can see what's changed in parameters by clicking this target button on the top right, and you'll see, oh, the only thing that's actually been changed from the defaults of this operator is this multiply. And you'll see here, obviously, that's where that is. But it would have gone through any of these tabs and found anything that was set off differently from what the default values are. So on every operator, there's also these question mark buttons on the top left, and these allow me to look at the documentation for that operator. So if I'm curious about maybe what this combined chops section of this math is, I can click on this question mark, and I can scroll down the documentation and read about combined chops. And in the documentation, you'll see sometimes there's these plus signs that allow you to expand and see more about the specific options that are available. So this was our first checkbox here, which is our kind of normal help kind of description of the operator. And then there's this one that has the blue and yellow, which will give you the Python methods and classes and the different code that you can use to access the tools and the functions of this operator through code, if you're comfortable with doing that. So those are the two different sort of help operations you can get inside of here. This I button will actually show you the information of how that operator is running at the time. This is the same as in middle clicking on the operator. Again, this is useful if you don't have a middle click button. You can just click this I. I do recommend a middle click or a scroll wheel mouse when you're using TouchDesigner, but if you're in a pinch and you're just out and about with your laptop or something and don't have a mouse, there are options to work around that. Moving on, I want to do a little bit of an overview of just what an operator is and how the general functionality of every operator sort of works. So operators connect together with these different, what we call wires. So you'll see these operators here with this, in this case, purple wires connecting between each of the operators. And then there's also these sort of gray lines with an arrow that's moving that we call links. So the wires get wired between operators kind of from the output to the input. So every operator, operators that have a left side, that's the input to the operator, with things that come out the right side, that's the output of the operator. And you simply click and drag to disconnect things or connect things. It's as easy as dragging out and connecting the input to the output. To disconnect, you can also right click and click disconnect on that menu. Sometimes it's easier than dragging away from the input of an operator. And then with links are usually created when there's a reference from one operator to another. So in this example, I have created the links to these values to this operator by putting this reference here. I'm going to get more into these references later, so don't be too overwhelmed by seeing this. And that's just showing that there's a data connection happening between these. But these are two different types of operators, as you can tell by their different colors. And so because of that, I can't link them with an input and output because they're not sharing the same type of data. They're referencing data from another operator. So how do you add an operator? So there's a couple different ways to add an operator. First of all, you can just double click on the network background and you'll see this create dialog shows up. And this allows you to add all the different operators there. Another way to add is you can drag out from an operator, from an output or an input, and then while you're still dragging, you can hit the tab button and that will bring up the operator. What's nice about that is once you select one, it'll automatically connect it. And then another thing you can do, like in this example, I have two outputs coming out of this operator, and I want to insert one with both of these outputs still connected. I can right click on the output of that operator and then add an element or add an operator in, and it'll keep those connections, allowing me to insert it in. Another way to insert, if I only want to insert one on a connection that's already existing, I can right click on that connection and insert an operator there and add it in. Okay, Okay, to dig in a little more of the actual op create dialog, on the top of the op create dialog, you'll see there's these different tabs going across the top. You might not have this custom one. Don't be concerned with that. That's when you download a custom operator class that somebody's made, that will show up, but you can ignore that for right now. Looking at these different selections, the different types of operators, you might notice a couple things. So there's some that have a light background, there's some that have a dark background, there's some that are grayed out. The dark background ones mean they're generators. So you'll notice like a circle generates a circle, what else? A ramp creates a gradient ramp. So those are all generators. And then the lighter backgrounds are a modifier or a filter, however you want to think about it. So those need an input to be able to work. And then the grayed out ones means that that operator is not compatible with your operating system. So I am recording this on a Mac right now, and the Mac doesn't have the Kinect or the NVIDIA tools available to it. So therefore they're blurred out there, or they're grayed out, sorry. To move around, you can hit tab through these operators, or the operator types. And you can also, as soon as you open, you can search for them by typing them in. And if it finds the one you want and you hit enter, it will add that operator from the create dialog just by typing. So, if you want to stay only on your keyboard, you can hit tab to open this up. You can type in what you want. You can hit enter, and it'll add it in all without leaving your keyboard, if that's something interesting to you. Okay, another part of the UI that didn't really make sense until now to start talking about is the palette. This might have been open when you first opened TouchDesigner. This is just sort of a library of pre-made components that you can drag into your project. The two ones that are most popular for me are the optical flow component out of the palette, and then the sharpen. But you should take some time and look through to see what's available here. Sometimes it's good to see like the different possibilities that are there in the palette. Another important thing is that you can actually create your own components and store them here. So if there's something that you use all the time, you might want to create it in TouchDesigner and drag it in there to reuse different components and operators that you made yourself. Okay, talking about operator flags, I'm going to close this palette. So to open and close the palette, you can click this button here on the top left. Okay, I'm going to get rid of my parameters for now so I have more room. But each operator, you can see, has these different flags, they're called, around the edges. And they do different things that are illustrated here. So first of all is the viewer active. So you can see here the viewer is off, here the viewer is on. I can toggle it on and off here. This lightning bolt is for cloning, but we won't get into that now. It's a little more of an advanced topic, but just to know it's a cloning protection. The bypass allows you to essentially mute an operator without like stopping the input flow. So, or you essentially, yeah, it allows you to do what it says it does. It bypasses it. So I have this edge here that if I turn off the bypass, you'll see it's actually putting the edge effect on. But if I turn it back off, I'm getting the same as what my input is. The lock will allow you to essentially, like it says, lock the operator. In this example, like it's freezing this frame. It's actually going to store this frame in memory too when I save it, which is an important thing to know. Sometimes you want that. Sometimes you might want to, hold an image in memory while the video or input, whatever, continues on. And lock is one way you can do that. And then going down to these sort of bottom flags, this blue is the view as backdrop. So you'll see if I zoom out, it's using that operator as my background. And then this bottom right one, this is to activate the operator. Now this is an important one that gets used in a lot of different ways across different operators, but if you activate it, you'll see the flags go away, but it usually gives you the ability to kind of click and drag on the operator in some interesting way. Or you'll notice the right-click options when it's not active are different from when it is active. So when it is active, I can change my different display types and things like that on the specific type of operator. I'll get more into that here in a second. Next, I want to jump into actually the different operator types. So we're going to start out with chops. So chops are our green operators, and chops, the word chop stands for channel operator. It's a shortened version of channel operator, which is not the most specific, or it's not the best description, but it's usually storing some type of numerical data, and that sounds very broad, and it is very broad. You can store a single value in an operator, or you can store like a whole set of values in an operator. The vocabulary around this is that like one single line here is called a channel, and each value along this line is called a sample. And so you'll see kind of in my Y direction here is the actual value for each sample. This is my sample number, and then the line itself is called a channel. So this one has a name, channel 1. And then you'll notice here, like audio is one example of a channel. Like chops actually will handle audio information, because if you understand how audio is stored, you have just individual values at different samples across two channels. So like with audio, you usually have a left and right channel, which you see here has a left and a right channel. You can see the number of samples. In this case, the samples are kind of streaming through the file, and then the values of each channel are represented in the vertical. So as I said, this is the audio, an audio chop. So this is like our audio file in chop. We also have our audio device out. So if I actually activate this, then you can hear maybe from my speakers here. That's the default music that comes with TouchDesigner in the audio file in, if you drag it in. Okay, so getting into sort of the different types of operators just within chops. So you have these different generators. So here's an example like of an LFO. You have a pulse, you have a trigger. So you see here in a trail chop, which is a great way to sort of visualize or to store kind of the memory of a channel, the different values that are coming in. So we have our LFO kind of moving up and down in the sine wave. We have our pulse chop that's showing each individual pulses, and then you'll notice our pulse chop going into this trigger chop, which is making this sort of it's making this attack, sustain, release envelope here in the third channel, and these are, you know, just clicking and dragging in each of these chops into each other. This pulse is actually what's triggering our trigger chop. Okay, other things that you can do with chops, you can take inputs from different devices. So if you see as I move my mouse around, this mouse in chop will give you the X and Y location of my mouse on the screen. Super useful for making interactive projects. You're not seeing, I don't have a MIDI device plugged into my computer right now, but like similarly to, you know, how we get the input from maybe a keyboard or something. In fact, this is our keyboard in, and if I hit the 1 button, that's what it's looking for. You see the keyboard trigger or keyboard chop triggering here. And if I had a MIDI keyboard, it would show me the trigger of the different notes or sliders or whatever MIDI device I have plugged into it. Okay, so now how do I use these chops in different ways? As I kind of hinted at before when I was talking about these links, you can create references between different operators. And with a chop, the way I do that is I first have to activate the chop like this, and then I can click and drag it onto an operator and drag it into like a variable. So let me disconnect this one right now. So you'll see there's no link here, and you see my amplitude is kind of set to whatever it is. But if I make sure this is active, which also this is important to note that if I have it selected, I can hit A and that'll activate the operator. Then I click and I can drag it onto the operator, and then I go to the parameter of that operator and release it. And then I can set it as a reference. I can set it as the current value, which doesn't keep that reference there. It's just the one-time sort of copy. Or I can export the chop, unless we won't get into exporting right now. But so right now I'm just going to use this chop reference. It's the most common one that you're going to use when you're wanting to drive values from a chop operator. So now you'll see this link is there. And if I change the value of this, you'll see on my trail that it's actually changing the amplitude of this LFO that I've made. So that was what was being driven. And as I change it, those are linked together. Okay. So that's what I'm going to cover for chops for right now. Let's dive into DATs. So DATs stands for data operators. And so where chops were storing numbers, DATs store text. And there's two main types, pretty much two types of DATs that you have to think about. So one is just a basic text DAT, and it stores just text like you would in a notepad. And then there's a table dat, which is sort of your, Excel type celled document. So you have rows and you have columns and you have values within those rows and columns. So what does that do for us? So the text dat, you can use it for a lot of different things actually. So there's basic text, right? Like this is just typing in, simply storing text. To be able to type in text, you do have to have an active operator. So if I start typing here, nothing happens. It'll just hit hotkeys and move me around. But to actually type in here, I can activate it and then it gives me a cursor and I can type inside now. So that's to use a text operator just as a basic text storage. Inside text operator, I can also create code. So here I've got a piece of Python code that's been written. And so if I select this, I can either right click on it and hit run script. And you'll see this script is simply creating a random number and adding it to this other text dat that I have. So I can do that. Or if you noticed also, when you right click, you can see what the shortcuts are for different commands. And so this is just Command R. So if I hit Command R over and over, you'll see it keeps on running that for me. So that's running just a basic piece of code. There's also DATs, if you notice in here, there's a lot of these that if I type in the word execute, these are different types of callbacks that can be run with different different listeners that are waiting for some event to happen to then run a piece of code. So this DAT is an execute DAT, and built into it are these different callbacks that on the startup of a program or startup of a TouchDesigner project, I can run a piece of code just as it starts up. Or if I want to run a small piece of code every frame, every end of every frame, I can do that. So I would turn on in the parameters, at the end of every frame, I want it to do this, and then I activate my code and I can say, print hello, whatever I'm going to do there. But I'm not going to turn that on, leave it on right now. You don't usually want code running every frame of your project unless it's something very small and very specific. Here we've got a web client DAT, super powerful thing. So I can actually give it a URL. Here I've got the TouchDesigner subreddit here. And if I hit request, it'll go out, pull in the JSON from that page and bring the result into my DAT. Then I drag that into a JSON DAT, which can then parse it nicely if I wanted to filter out, specific data from that and maybe use that for some sort of visualization of some kind. I could. Okay, moving on to tables. So tables, like I said, is storing data in rows and columns. So you see here I have a kind of random set of X, Y, and Z data in 3 different columns with a bunch of different rows. Again, I can activate it and edit this table if I want, or if I need to add more data, I can add a column below and start writing whatever I want. I can also add different columns if I wanted to set the different size of the table as I'm creating it. I can also delete columns in the same way and delete rows in the same way. And then when I want to use that data, I can reference it in the following way. So in the code, or in when I'm making a reference to a table, I want to use this sort of syntax here. So I say that I'm going to use the operator table2. That's my name of my table up here. And I'm going to pick from row 1, column name, with the column name Y. So you can reference a column in a row either by the actual number, like ID of it, which are labeled here, or I can actually use the first row or first column's value in as a string as my value. So this will actually get from my row 1, column Y, this value. And as you can see, I've put that. I put that in this evaluate dat. So an evaluate dat is also, instead of running a piece of code, I can just give it an expression and it'll evaluate using that expression what the value is. There's a lot of different ways to use an eval that you can see in my tutorials, but I won't dig too deeply into that right now. So getting back to kind of the callback ideas of code, this is where things get pretty valuable as far as the power of a dat. And if this is feeling overwhelming too, there's plenty of people who don't use DATs for this. I will say now that this is a more advanced thing to deal with. If this is intimidating to you, feel free to kind of skip ahead if you're a little intimidated by when you see code. But it can be super powerful if you learn even just a little bit of it for projects like this. So here I'm using a chop execute. So we have a chop here, an LFO chop that we saw from the last operator section. And I have a chop execute. So it's looking at that LFO as the reference chop. And I'm saying whenever the values change, I want it to run this piece of code. And so this is saying for this text output dat, I want to change the text equal to the value. And the value, as you can see up here at the top, is the numeric value of the changed sample. And I'm setting the value of the data in this dat, this text dat, to whatever the value is of this chop, just to give an illustration of what these chop executes do. So you can have things change. You have code run based on if a parameter changes, if there's a change in a touchscreen panel, something happens. There's also you can also have another dat whose data changes, execute code. Like in my example, the web one before, you can say if that website output changes, then I want to run some amount of code to say like, okay, this has changed, I want to process it. Next operator we're going to talk about is our SOPs operator. So SOPs are the original kind of geometry of TouchDesigner. So 3D geometry being used in TouchDesigner. I will say that we'll get into POPs in a second, and POPs do replace a good amount of SOPs in TouchDesigner. But there are tools that are still useful in SOPs that don't exist yet in POP. So we're still going to go through it just so you get an idea. So SOPs are surface operators. They store 3D geometry. So we have like a 3D sphere. We have a box. You notice I'm activating first to be able to drag these around. I'm hitting A on my keyboard and dragging around. You can create a box, create rectangles, create grids. You can also bring in different files, different things like that, of 3D geometry. To navigate around in a SOP, like I said, you activate it, and you can drag left click to rotate around. You can middle click to zoom in and out, and you can right click to pan. And then you see kind of like some of the other modifier tools that you can use with SOP. So here we have a sphere SOP. Two different sphere SOPs that are two different sizes. You'll see this one is 0.1, and this is a larger sphere, size of 1. And I'm using this copy SOP to copy a copy of this sphere onto all the points of this sphere. So you see the copy SOP there, then this is the convert SOP. If I wanted to, let's see, what I changed here, nothing right now. So I'm changing all types into polygons here. So if I middle click on my SOP, I can see the copy SOP has 42 primitives, and here I have 31,000. So I went from having just sphere primitives into a bunch of geometry. And this is a great use of the middle click, by the way. There's also different views you can have of SOPs. So here I have the wireframe turned on. So if I hit W, I can toggle just my kind of texture mode. And then if I want to see all the points and lines of that geometry, I can hit W to view it in a wireframe mode, which can be super helpful. Then there's more display options as well. If I zoom in here, it might be kind of hard to see, but on each of these corners, there's a small blue number, and you can turn that on by doing the different display attributes on the SOP. So if I go into display options, you'll see I have these SOP markers that I can turn on and off. That'll allow me to see the number of points. Sometimes it's useful to know which index a specific point is within the geometry. So yeah, there's kind of a lot of fun things you can explore within this display options to be able to visualize in the operator what you want to see. And then here, this is a great example of something that doesn't exist in POPs right now. So you can do different merges and Booleans. So for example, I have this box here. That's kind of a shorter box. And then I have this deep, longer box. I can use a Boolean SOP modifier to say I want to subtract subtract the B from the A, and I end up with this custom piece of geometry that was made. Super useful. Next operator we're talking about is our tops, our purple operator here. and TOPS stands for texture operators. So TOPS hold different pixel data, both image and video, but also you can just store data as pixel information as well. So this was a very common way before POPs to store values for, let's say, a particle system. You'll see here I have a movie file in that's just an image, that's a static image. I also have a movie file in here that's a moving video. Here I have a noise generator that's storing random pixel data, or it's just creating random pixel data. TOPS have different views available. So here's kind of our default image viewer. That's just the pixel data, kind of the way you would expect it to be. But sometimes it's useful to view the different pixel data split out into its individual channels. So if you imagine each pixel holds a red value, a green value, a blue value, and an alpha value, this normalized view, which is activated by activating your top and hitting N, will show you all the red values separated from the green values, from the blue values, and from the alpha values. Not only separated, but also normalized so that the darkest pixel or the lowest value is set to black and the highest value is set to pure white. As we'll get into, sometimes values will go past 1 and past 0, and this view will kind of compress all those down into the visible spectrum of 0 to 1. There's also, like I said, you can store pixel values inside of a texture operator, and you can actually pre-visualize what those particles look like. So if you imagine red, green, and blue values representing X, Y, and Z values in 3D space, this will, by viewing as points, which is activated by using the V button when you're viewing an operator, will show this 3D view of the points that you're generating based on those red, green, and blue values, those pixels being in XYZ space. So these three are showing the exact same video, just in three different ways. Okay, getting into the generators that are available in TOPS, you can generate just flat colors. You can generate shapes with circles and squares. You can also create gradients in different ways. These are both two different types of gradients. Obviously, you have linear gradients and circular gradients. The modifiers, you'll recognize these if you're familiar at all with like Photoshop. You can take an original texture operator and run it through a blur, an edge, emboss, different levels, which is kind of like the different curve types and things to change the brightness, gamma, invert, contrast, things like that. You can use the constant not only here, like you see a constant as a generator, but a constant can also be something where you can add color by multiplying it over the top. And then there's hue, saturation, and value adjustments that is a modifier. And then this is maybe getting a little more complex, but you can also do math on the particles, or on, sorry, not on the particles, on the pixels. So if you imagine each of these values being stored as red, green, and blue values, you can do different math based on what the values coming in and out are. You can rearrange them from a range, in this example, 0 to 1 for the blue. You're rearranging it from a range of 0 to 1 to 0 to 0.1. Okay, compositing. So this is where we can kind of join different textures together. The tops, you'll see here, I'm just using different types of compositing to add things together. The composite top is kind of the Swiss Army knife of compositing. You can drag as many different textures into a composite and choose the operation that you want to combine them with here. Then there's also like kind of the specific compositing tops. So like an add will add two textures together, multiply will multiply two together, subtract. And then you can also composite with something like a crossover, where this is actually taking two operators and letting you crossfade between the two of them. So this is something where you can either use this to like select a perfect blending point and leave it there, or if you are transitioning between two things and you want to have like a nice transition, you can use a chop, kind of like what we showed earlier, and transition between the two operators. Okay, selection and routing. So this is something where most of the operators actually have this functionality as well, but it's better illustrated through tops than anywhere else. But I've got these sort of three options here, these three inputs that are all going into this switch, and then I'm driving this switch with a chop, as you can see here, and it's switching the input to the different operators. that's one way to kind of do selection and routing. Another way to do selection, so sometimes you'll have a texture somewhere in your network and you want to bring it into your current context wherever you're at. You can add a select top and then reference with that link. You reference that texture operator that you want to bring in here and start some new network with. Okay, feedback. The feedback top is one of those super powerful operators that can take a little bit to wrap your brain around. I won't go too deep into this right now, but you'll see I have this basic feedback network right here, which has an input where I have a circle going into a transform, and then into my feedback, it's going out to this crossover, which the crossover has the original transform and then the feedback coming into it, and then I'm kind of weighing it more towards the feedback side of things. But the way to think about a feedback is that the input to the feedback is only for the first frame. So a feedback takes in a frame from this input, and then everything from then on comes from this target top. So in this example, I'm going into my feedback, starting whatever I'm doing here, going into my crossover, and then the result of this cross fade, I'm dragging back in, or I'm bringing back into this feedback for the next loop. And so it's just constantly going in this loop. It starts here and then constantly goes between this loop. Also, if you might notice, I'm using this reset to reset the feedback back to nothing. So the effect of this crossover is that I get this trailing effect behind it. But if I want to clear that effect, I need to reset it with this reset button inside the feedback. Okay, tops also have lots of different types of outputs. So this is normally where when you're making something and you want to share it online, you might use a video file out, or if you're just creating video content that you want to save, there's a movie file out top. There's also, if you're streaming like at a live event and you want to stream wirelessly over NDI, there is an NDI out. There's also video stream out, which if you want to stream directly to something like YouTube, you can set up the parameters in here to stream directly to YouTube Live. Okay, and one quick note about point clouds and tops. Again, this is something that's kind of going away with pops, I think, but if you're watching tutorials, it might help you to understand that point values for a particle system can be stored in a top, as I was kind of showing before. So here I have this noise value, which is doing noise in red, green, and blue values. And that noise is representing XYZ values in sort of 3D space. I'm using here a point transform top, which will actually assume that the values coming in are 3D particles or 3D points, and it's going to rotate them. So like I'm rotating here with this little expression to rotate them in 3D space, and then I'm visualizing here in this null. Quick point here while we're at it. So like you'll see this little script I'm writing here. So this abs time.seconds is a great thing to kind of take note of. So it's a way to reference how many seconds have gone since the beginning of this project. And you know, I'm multiplying it by 15 here to speed it up a little bit. It's a thing you'll see a lot of the times, that this abs time.seconds reference will be used to kind of generate some automated animation for you. Another thing is you'll see nulls. So nulls exist across all the different operators. So again, if I type in null, you'll see as I tab through all the different ones, there's a null in every single operator type. And those don't have any real functionality, but they're great for holding space, or like when it's usually as a rule when you're transforming between one operator type and another, you usually want to put a null in, because if there's a link referencing, the link reference is to the name of an operator. And so if I'm linking this null out to another operator and then I decide I want to change something towards the end of my chain, I don't have to like put in that thing and then relink to that operator. I can leave my null as that sort of last step and delineate what the beginning and end of each, or what the end of that type of operator is. Okay, another kind of more advanced thing, but I'm going to go over it just in case it helps anybody as they're going through their learning or going through a tutorial. So texture operators, by default, like a texture operator will be an 8-bit RGBA. And what that really means is like it's storing the pixels only in sort of the visible space. So like we store images in this 8-bit RGBA from kind of values of 0 to 1 in this situation. And it kind of controls how much memory is being used by that operator, but it also controls like what range of numbers are allowed to be stored. So here you'll kind of see where that difference comes into play. So if I middle click on my noise operator here, you'll see I'm generating from the start a 32-bit float RGBA. Now 32-bit float, like I said, 8-bit is what we see in the visible spectrum, or it's only what goes between 0 and 1, what will show up here as like, 0 to 1, black to white, 100% red, 0% red, only shows up between 0 and 1. But sometimes you want to store data in these pixel values that go past 0 and 1, like I said. So a 32-bit float is kind of the largest, biggest option, most precise option too. It has the most decimal points that can be stored, like the longest amount of decimal points that can be stored in a pixel value. So here's kind of an illustration of how the different pixel types like make a difference, I guess. So you'll see here these reorders are what I'm using to change my pixel format value. So from here, we started with a 32-bit float. Here, this reorder, I'm changing it to a 16-bit float. Like if I right click here, you can see 16-bit float. Here, this one's changing to an 8-bit RGBA. And then here I'm changing just red and green, just RG, just 32-bit RG. So you'll notice like my blue values are gone completely from here. So just by changing what pixel format this top is storing, I'm actually losing data. So again here, like these four have RGB and A values all in each of them stored separately. This one, I just took out two different sets of data because maybe I'm only caring, for example, about this being an X and Y values. Like you'll notice if I look at the point visualization of this, it doesn't go into 3D, like into the Z depth because I got rid of that data. Where the original 32-bit float is a full 3D floating shape, right? The 16-bit float, if you can tell, it's maybe hard to tell, but like the precision on that is going to be a little less, but it's also storing less data, it's taking up less memory. And then here's a big thing to notice, like if I change it, when I change it to limit it to an 8-bit RGBA fix, it's limiting it to this box between 0 and 1 values for every single RGB or X, Y, and Z data. So when these values go past 0 or past 1, it actually clamps it off, right? And again, here, I'm only using red and green values, so that way so I'm only getting one set of values. And then in the last one here, I'm just doing a 32-bit float mono, so it's still 32-bit float. I've got values from negative 0.5 to all the way to 1.5, but it's only storing it in one dimension, hence giving me, when I visualize it, just a single line that represents what data is being stored. So I took all this data, and just by changing the pixel formats, I'm changing the different types of precision, how much memory is being stored, how many different values are being processed through these different texture operators. The next main operator class, and kind of the newest one, and the one everybody's the most excited about right now, are POPs. And POP operators, POP stands for point operators. So they're made up of points, vertices, primitives, and they have the ability to assign different attributes to each of those different classes of data. In a lot of ways, they replicate SOPs, and lots of the things that we previously would have done in texture operators or in TOPs, we can now move to POPs because instead of having to store different pixel or point cloud data in these sort of textures with only RGB and A values, we can now just add more and more attributes to kind of one set of data. So that way it's all kind of stored together in one place and can be like combined in a lot simpler ways. So as I said, there's kind of three different classes. We have points, we have vertexes, we have primitives. Here from this basic rectangle pop, you can see there's 4 points, which are here in the pop to dat. That's super useful. I'm in the pop to dat. I'm changing the extraction to points to look at the data for each of the points. You'll see that there's 4 points. It shows their positions represented by P, their normals, and their texture values. Yeah, so here I have my vertexes showing the 4 different lines that are represented in here that represent each of those 4 corners. And then I have primitives. So here I just have one primitive that's taking this 4 different vertices and saying I'm connecting these as a quad type primitive. You can probably ignore to start out with a lot of this vertex and primitive stuff to start. Those are a little more advanced. A lot of what you'll be seeing in pops will likely just be within the point data. But it's good to know that this vertex and primitive data exists. And as you get more advanced, you'll dig into those. So the different types of generators, different things you can just generate out of a pop. Similar to SOPs, we have different 3D geometry like a cube, spheres, you have toruses, you have 2D objects like circles and rectangles. You can also create a grid, and similar to SOPs, you can use the W hotkey to show the wireframe instead of the sort of texture-filled surface view. And then you also have a point generator, which is a super valuable tool that they've added with pops. Here I can, in the point generator, I can say whether I want to generate a bunch of points in a sphere or a torus or just a flat circle. So those are our generators. We can also generate pops, obviously, from converting from other operators. So here we're showing how I took a movie file in. Here's the famous TouchDesigner banana, down-resing it a little bit, and then there's 2 different ways to convert a texture operator, a top, to a pop. I can use this polygonize to trace out something from this operator. So I'm obviously using this to create a piece of geometry tracing out my banana. Or if instead I want to represent every single pixel on this image with a point, I can just convert straight from a top to a pop using the top to pop. And if I zoom in real close, you can kind of see for each individual pixel, I have a point. So depending on what you want to do, you can either create outline geometry or just point-based geometry. Okay, and then getting into attributes. So as I said, by default, when you generate something with this point generator, I'm generating a torus, and by default, it's coming with a position and normal data for each point. And you can know that because in the bottom left hand of a pop, you can see these the letters that will show up saying which attributes this pop is generating. What are the outputs of this pop? And so we start out with a position here. And then as you update a pop operator, so here I have a noise, and if I zoom in, you can kind of see the noise is animated. Like if I click on my parameters, I'm using that as time.second, so I'm dividing by 11 to slow it down. And it's animating my noise, and I'm seeing here that the position is the thing that operator is updating. And if I look at the output scope of this operator, it's outputting or it's updating the position of that attribute. Okay, and then, so like I said, from default, we had the position and the normal, but you can also add new custom attributes to your points, and they can just be arbitrary. You can add whatever values you want. So here I'm using an attribute pop, and I'm creating a new attribute called silliness, and by default that value is going to be 0. It's only going to be a one-dimensional, so I can add, kind of like with the texture operator, we were storing 4 values potentially, like as red, green, blue, and alpha. Here you can do up to 4 different dimensions of our attribute. So here I'm creating an attribute called silliness. I'm also adding here a kind of reserved variable called point scale, and I'm saying the default value for that is 2. And you'll notice the other kind of reserved ones here, I can add a normal if that doesn't already exist, color, texture, point scale, line width. Those are all attributes I can add there. I also added a section here from the TouchDesigner learning site with the link. These are all kind of attributes that you don't want to, or that are reserved in different ways. It can be useful to know some of these for multiple different reasons. One of which is that, like with this example here, I used another noise, And as the output, I said I wanted the output, the output of the attribute for this noise, I want to name it color. And by default, my operator viewer went ahead and visualized the color of those points so that they had those color values. So that the only reason that happened is because I named it color. So if I named it colors instead, then it wouldn't actually show that in the viewer. So it's kind of a nice thing to, when you know to name it the exact thing, it will kind of be smart about that, right? This is a little more of an advanced thing, but like when you're referencing attributes, you can do things where instead of referencing just the attribute name, you can reference which dimension within that attribute you want to reference. So like what I'm doing here, I'm using a math mix pop to simply set the color to a new order. So obviously, like from the beginning, the color values were color 0, color 1, color 2, and color 3 for the alpha. And then I'm going to reorder that so that my color 2 value comes first, color 0, color 1, and color 3. So you notice like all I'm doing from here to here is I'm changing, if you can tell, I'm moving my RGB values to a different position. You can do that. There's kind of two different ways you can reference the attributes like this. So here I'm doing it with the color and then parentheses to reference the number of the value. Or in this example, I can use BRGA instead of, originally it's RGBA, obviously. So I'm switching the B to the beginning and moving things around a bit. Just different ways to reference the different values within an attribute. Okay, attribute visualization. So I showed before, like I made that silliness value, and here I'm using a random pop to kind of assign random values to those silliness values. And normally when I do that, I wouldn't actually see those values at all visualized. But if I activate and then right click, I can then turn on a display attribute and display that attribute using colors. I can use dots, I can use vectors. So like a common one might be for the normals. I can create these arrows that'll show what direction my normals are facing. And so now I actually get a visualization of what those normals are doing. I'm going to turn those off for now. And then, like I said, like silliness might be something like, it's instead of showing these colors, like I want to see when I'm editing this silliness value, I want to see what those represent. So like, if I'm changing what the randomness of these are going to look like, I can see that distribution here. Anyway, super valuable tool when it comes to pops is to be able to visualize like what they're doing at different steps. Because again, these are storing lots of different attributes all within different point data. Okay, the copy pop, kind of like when I showed copy SOP earlier, you can take a piece of geometry and you can copy that piece of geometry onto each of the individual points. So here, we have our points and then we have a small cube, and the copy pop will allow us to copy that cube geometry onto each of those points. And within the pop, I can also say which attributes I want to copy over from my point template. So here I'm copying over the color, and you'll see this is actually a good point too to show. When you middle click, it'll show all the different attributes that are being stored within your point. So right now I have point attributes of position, color, normal, point scale, and silliness. But then after I copied over, I only chose to bring over color with this new information. So right now my point attributes are just position and color, and then I'm also working with this normal and texture that came from my box. There's a couple different ways to render out pops. Maybe I won't go too deeply into this, but you can use both the input directly into a geometry. Sorry, that's this one right here. I can go directly into a geometry component, which I'm going to get into components in a second, or I can use instancing. Instancing is a little more of an advanced topic. I'm not going to go super into it right now. The pop to dat, I'm going to talk about just real quick for a second. Anywhere in my system, I can like drag a pop to dat operator in to view the different data for points. But, in my example here, I've got 4,000 points. You might be working with a system that's got 1,000,000 points, and you don't want those loading into a DAT like this every frame. And because if you did, it might just like bog down your system, but you still want to be able to visualize what's going on here. The pop to DAT is super valuable. And then they've added this in a lot of new places where you can thin out the values that show up here. You can randomly thin them out by using this thin random, or you can thin out a range if you'd like to just only do a certain range from the beginning or from the middle of it, if you want to only get the last values. There's a way for you to kind of sample only specific parts of it. Here, as I said, I kind of showed at the beginning, you can extract the point data, the vertices data, or the primitives data. Most likely you're just going to care about the points for a lot of the things you're going to be doing. But yeah, the pop to dat, super valuable, great way to kind of debug things when you're trying to figure out what's going on. Some of the modifiers and filters that are super valuable, like one of the calculation tools actually that you can use with pops, is that you can do these proximity calculations. There's both proximity and neighbor, or kind of is the other pop that kind of allows you to do cool stuff like this. So this is actually allows you to do calculations across two sets of points. So here you can see this proximity is taking this kind of random floating blob and my original points, and then finding within this certain distance a number of points that it can then connect lines to. So you can get lots of cool kind of plexus sort of effects out of this, but it's also able to add different like types of output too. So if you want to add those lines as data to then calculate on later on, you can add those as attributes that get stored then with the points. Or in this example, you get these primitives that get added to it. I'm not sure why I really added this, but I think it's interesting, especially if you come from like a motion design background, that pops also allow you to bring in Alembic files, which allow you to animate kind of 3D objects within TouchDesigner. This is a great new thing that's just become possible with pops. And so you can drive the animation of those with whatever you want, which is kind of amazing. Okay, last operator type I want to talk about are comps. Comps stand for components. There are black operators, gray. And the common thing with components is that they can contain entire networks. So it means that unlike other operators, if you take a comp and you double click, you can go inside of it and it can contain an entire new network. So in my project here, as you can tell, these are all what are called base comps. They're essentially folders that hold this entire network inside of it. What else can a comp do? You can also, there's a comp type, like here, you see here, this is one of the only types that has these column names. So there are 3D object comp types, there are panel types, these other types, just to catch all, and dynamics. Dynamics are definitely more advanced. You don't need to worry about that for a while, probably. The most common one here is the base, which is just an empty folder, essentially. The window I'll get into in a second. The panels, these are ways to make a window or a visual like interactive component. So that's where I'm showing here. This is a container, and you'll see as I drag my mouse over it, I can get the mouse data within this container. I can here get the U and V, or the X and Y data for where my mouse is, and I can set this circle to it. If I click, you'll see I can get interactive clicks. If I click this button, I've toggled this, so now that my circle is blue. And this is the way that you can make like an interactive touchscreen project with TouchDesigner, is using these containers. If I deactivate it and double click in, you can see this is my network inside of there that's driving things. I have this panel chop that's pulling in the data for my X and Y values. I have my circle here and my transform top to move my circle around. And when I activate it and move back out, you'll see that's what's driving this container. Okay, one of the last main components I'm going to talk about here is a window operator. So as it says here, you can create a floating or fixed window to display an operator's context. The perform operator at the root of every project is a window comp. You can create windows that are full screen, borderless, and always on top. This is like for if you use doing like a full interactive installation or like a visual performance, like a VJ performance. And then if you're in the full screen, you can hit escape to exit out of it. So here I've got a movie going into a floating window that I made here. So if I go into my window and hit open, it came on another screen, but now I've got this nice floating window. Then this one here, if I turn it to my current display that I'm on right now, if I hit open, it'll go full screen and play whatever operator it's referencing full screen. So this is the way to do your actual installation projects is by using a window operator. And you'll see even this my floating Dean cam down here is a window operator as well. Okay, one final thing about components is that different from all the other operators, you can actually parent components to each other. So here in a kind of basic rendering setup, which I'll get into here in a second, the light that I have here in my rendering setup is rotating around the center of my project. And so if I just rotated the light itself, it would have just spun around on its head. But I want it to rotate around the middle of the project. So I have this null component that is just sitting kind of in the middle of the scene, and using my abs time.seconds, I'm rotating it around the middle. But then to make my light connected to that, I'm connecting this null parent to the light. So that way, as this rotates, my light will be attached to it. And this is one of the few things here. Like the only way that parenting really gets used in this sort of way in TouchDesigner is with these components, especially in 3D kind of transformations. I guess you'll also find that in like containers, creating UIs and things like that. But I guess I'm showing that here. So like using containers, I have these 3 different button containers, but I want them all to be combined in the single kind of UI element that I've made. This is where, dragging these all into those gives me a single container that I can then reference as my UI somewhere else. We're in the home stretch. I wanted to talk about a couple more things that I think might come up in the tutorials that you look at, or things that might just be help you understand how TouchDesigner works a little bit. And in this network here, I wanted to illustrate how you can kind of convert the different data types between each other in TouchDesigner, and how that can, why you might do it is like there's a lot of different reasons of why you might do this, but at least to give you the understanding of that it is possible and how this data is being represented. Because really, in TouchDesigner, all these connections are just moving data around in different ways, and they can usually be represented across all the different operator types, right? So here in this network, I've started with a sphere, which is just a piece of geometry, right? A SOP geometry with all these different points and lines. I'm putting it through a noise SOP that's animating around. Here I have a null before I change it to a different type of operator. So here I'm converting this SOP data into a chop. And the chop is simply taking all the points from that SOP and translating into channels of X and Y and Z locations, right? So this is the same data, right? And then I'm taking that chop data, I can convert that chop data into top data, so into pixel data. So instead of being X, Y, and Z data represented in 3D, I can then change it to RGB data. So this is a chop to top. So this actual data is the same as this data. Again, not too much of a stretch to see here that we can also convert our chop data into DATs. So these are all the different XYZ values written out as strings. So I wanted to show here, there's different ways, like for example, there's certain effects I might get by that I want to get through limiting, like here's an example. So I'm taking this point data, that's XYZ data, I'm bringing it into this limit, and then I'm rounding it. So that way, I want to put this on like some sort of grid. And so we'll see the effect that comes out of this rounding is like this sort of cool pixelated digitization that happened. Now this would have been a harder effect to get from just going directly through SOPs. But using the top data, the top modifiers, I'm able to transform the data into a way that top can understand it. And then, so this is the conversion to tops here. To get it back to a SOP, I wanted to kind of show the whole full cycle here. To go back to SOPs, I first have to change it back to chops. So I go from a top back to a chop. I make sure I do the full image. And then I go from the chop back to a SOP. You'll notice one of the things that might be interesting here is that, like, even though like if I just convert it straight over, I don't actually get all the connectivity correct in my SOP unless I bring that connectivity information in. So here I just have like a null that's referencing my initial circle, and that allows me to then say the connectivity is going to be referencing this SOP, so that when you put all these points back together that are in this order, this is the way that I want them. Like, this is the way I want them all connected together. So yeah, just converting. Just wanted to show, kind of illustrate here that the different data types can all kind of move between each other in different ways. Sometimes you have to convert through a different operator, like to be able to go from a SOP to a top, I had to go through conversion to chops first. And there can be inefficiencies and stuff that happen from this, but this does kind of illustrate that it is possible. And with pops, you can kind of swap all around between all these. I didn't add it into this tutorial, but perhaps if you want to see that, let me know, and I'll make one specifically about converting for pops. Okay, like I said, I wanted to show kind of the anatomy of a render setup. So when you're creating all your different like data, your points information, your SOPs, whatever it is, and you're creating a 3D scene, there's kind of this basic rendering network that needs to exist in order for you to be able to render out your different objects and data. And this is kind of just an anatomy of what those are. So the first thing to think about is your geometry itself. So this can be either SOPs or pops. So here I have a torus pop that's going in to a geometry. One important thing to note is, like, if you just click and drag a geometry in from the add operator dialog, you'll see there's no input here. By default, it has this torus inside of it. I don't usually like doing things where I keep all my geometry inside of my geocomp. I like it to be referenced from the outside. And one of the hacks, or not hacks, but just the way to do it, is if you drag an output from a piece of geometry, a SOP or a pop, and then hit tab and then add your geometry that way, then it'll add that input. It'll automatically use that whatever input reference geometry is as the geometry that you're rendering out. So there's that. So we have our geometry added, and then to add like color and surface to the geometry, we have our one of our last operator types here that we haven't talked about are materials. So materials are just for 3D material and surface like assignment. So here I have a Phong material. You can also add a constant material, which doesn't require any lights. It just gives a flat surface to whatever your geometry is. You add that material, you can drag it on here and you can drag it on here and add it as a material, which is the same as dragging that into this render tab under material. So that's where I'm assigning this pink color to my geometry. Then because I picked a material that does use light, I need to add a light to this render setup. If I added this Phong material and there wasn't a light, it would show up as completely black. So with my light there, I can change the directions, I can change the intensity, change the color of the actual light so that what gets reflected off. Then to pick the actual perspective that I'm going to be seeing my geometry from is I add a camera comp. So here within this 3D objects column, I've got a camera. And if I want to move my camera around, I can activate it and I can kind of click and drag around, just like with our SOP viewer. I can frame up however I want my render to look. So camera, which you can also change your projection types to being perspective to orthographic or some mix of the two. And then there's the render top. So the render top is where you're actually collecting all those things together. You can see all the lines kind of connect through it. You say what geometry, what lights, what camera I'm going to be rendering out. And then this is where the actual generation of the pixel data that you're going to be taking off and rendering out or streaming or whatever you're going to do with it. This is what actually renders that. So these are the required things for a render network: geometry, material, light, camera, and a render. Okay, now we're going to talk quickly about customizing a component. So the components, like I said, can contain a whole network of things. And you'll run into, sometimes people will make custom components, and you might be interested in how that works. You'll see here I've made this custom component with these parameters. If I hit reset, it starts over this effect. I can then change like my filter size to make the kind of lines bigger and smaller, make the crossover fade to how quickly this effect takes place, how extreme it is. And you can create these pretty simply by right-clicking on any component and say customize component, and you'll get this dialog that allows you to add different parameters. And really the shortest way to do that is to go into an operator and then, let's say maybe I want to change the period of my noise. I can go into my noise, I can go to the period, I can just drag this onto the custom parameters, and I can say bind parameter as master. And now when I go back up, I've got this period, and I can change what's inside of this operator without having to dig in and go into the network. So, if you want to make some component that does a very specific thing, you can build a whole tool that doesn't require you to go inside and change, changing the constants or changing the parameters inside of your network. You can just do it all from this kind of like top level. Super powerful, super useful. Again, I won't get into all the things you can do with that, but just knowing it's available, I think is interesting. Okay, just to wrap things up here. Again, hopefully this was helpful. I'm going to make this project file available to everybody for free on my Patreon, and I definitely would love to hear any feedback you have about this tutorial. I think I'll probably make this again in the future as I get more feedback. So I definitely want to hear what made sense to you, what you missed out on. What I went too fast on, what I went, too much, what I went into too much detail about. But yeah, anyway, I hope you are excited to get into TouchDesigner. I definitely want to see what you make. I get so excited seeing that people are learning it. And so like your first project, if you make something and post it online, definitely tag me in it. I would love to see it. I will repost as many of those as I can see. And then, like I said, too, it's available on my Patreon. You don't have to support me. If you want to see my project files, I do make that required for people that pay. And then I also have a couple tools that are specifically made for my Patreon followers. But then beyond that, here you're on my YouTube channel, I think right now. So if you want to subscribe and hit like so that you can see more of my videos as they come out. I love having people that are learning from what I'm doing, and it's super fun. Also, I try to make a little tool here that will allow you to browse like all the different other tutorials that I follow and people that I learn from. So if you activate this little tool, you can kind of preview all the different TouchDesigner developers that I follow on YouTube and I've learned from and I owe so much to. So definitely go check them out, go subscribe to them, and I hope you learn a lot of amazing things on your TouchDesigner journey. Just also to end up, I am a freelancer. So if you are working on a project actively and you need some help and you want to pay for somebody to come in and help you with your project, find me on my website and contact me, and I will see if I can help you out. So I will leave it at that. I really hope this helps you out, and I will see you at the next tutorial.